Hello everyone. We have learned about straight lines, one of the three elements of planar alignment. Today, we will learn about the other two elements, circular curves and transition curves. The circular curve and the transition curve together constitute a horizontal curve. Let's take a look at the circular curve first. The circular curve is a commonly used alignment in planar geometry. Single curves, compound curves, and switchback curves, which are commonly used in road planar geometry, typically involve circular curves. At the turning point, i.e., intersection, where the direction of the route changes, it is possible to insert circular curves tangent to straight lines at both ends to achieve a change in the direction of the route. Circular curves of different sizes are selected based on the topographical conditions to make them more suitable to the terrain and visual perception of drivers. Circular curves have the following characteristics. First, the radius of curvature at any point on the circular curve R equals constant, which is easy to measure and calculate. Second, the vehicle traveling on the circular curve is subject to centrifugal force because each point on the circular curve is constantly changing its direction. If the velocity is constant, the centrifugal force is constant. Third, the vehicle traveling on a horizontal curve occupies a greater road width. Fourth, poor sight distance. When the vehicle travels inside a circular curve, the cut slope or obstruction restricts the viewing line. The sight distance is poor, which can lead to an increase in accident frequency. Fifth, the long and flat circular curves with a large radius have the characteristics of good alignment, smoothness, and driving comfort that are commonly used in road design. Therefore, how to calculate the radius of a circular curve? It is related to the force analysis during vehicle turning. When the vehicle travels on a curve, it is not only affected by gravity but also by centrifugal force. In order to reduce the effect of centrifugal force and ensure the stability of vehicles driving on horizontal curves, it is common to design the road with a unidirectional cross slope, typically higher on the outer edge and lower on the inner edge, i.e., superelevation. According to the derivation, the equation of the radius of the circular curve can be obtained. Therefore, the radius of the circular curve is related to the lateral force coefficient and superelevation cross slope. The existence of the lateral force coefficient has a negative impact on driving. A higher lateral force coefficient can affect the safety, economy, and comfort of vehicle driving. Therefore, considering these factors comprehensively, an appropriate value of mu is provided between 0.1 and 0.16. Different values are applied based on different grades of highways. In addition, an excessively high superelevation rate can lead to the risk of the vehicle sliding along the composite slope of the road surface. Conversely, too low of a superelevation rate cannot counteract the centrifugal force when the vehicle turning. Therefore, the specification also provides the specification for the cross slope of road superelevation cross slope. Finally, let's take a look at the minimum radius of the circular curve. An excessively small circular curve radius cannot ensure the safety and comfort of vehicles turning. Therefore, Technical Standard of Highway Engineering gives three values of the minimum radius of circular curve that directly impacts driving safety, namely absolute minimum radius, typical minimum radius, and minimum radius without superelevation. The absolute minimum radius is the smallest allowable radius that ensures safe travel for vehicles at design speed on highways of all levels. It is generally not used unless necessary. The typical minimum radius refers to the minimum allowable radius that ensures safe and comfortable travel for vehicles at design speed on highways of all levels. The minimum radius without superelevation is the minimum radius used for circular curves, where the radius is relatively large, and safe vehicle travel is ensured primarily through the friction between the tires and road surface with lower centrifugal forces. The above is the determination of the minimum radius according to the specification. A larger turning radius is conducive to vehicle driving safety and comfort. Therefore, when selecting the radius of a circular curve, a larger radius should be used whenever possible, provided it is compatible with the terrain and other relevant conditions. However, if the radius becomes too large, its geometric properties and driving conditions are not significantly different from straight lines. This can lead to misjudgment by drivers, with adverse consequences. Additionally, it is unnecessary to increase the complexity of calculation and measurement. Therefore, the specification stipulates that the maximum radius of the circular curve should not exceed 10,000 meters. Dear students, the above is the relevant content about circular curve design. Have you all grasped it? That's all content for this lecture. Goodbye, everyone.